Now that we've had an introduction to some of the important concepts in graph theory, we're going to move on to something a little bit more focused. We're going to talk about some special types of walks on a graph. Now, we've talked about walks before, but we're still going to review the definition, and then we're going to review some of the other definitions of other special walks that we've already talked about. That includes the definition of a path and the definition of a cycle. And then we're going to introduce some new definitions. One that is called a trail, which is kind of what I'll eventually call the edge version of a path. It's like a path, except with edges instead of vertices. And then we'll talk about what a circuit is, and that is very similar to the concept of a cycle. So if G is a graph, remember that a walk in G is just a sequence of vertices where if you look at two vertices next to each other, they form an edge in the graph. So V1, V2 is in the graph, V2, V3, all the way up to Vn minus 1, Vn. So as an example, here's an example of a walk. And here we have a bunch of vertices. Notice that we can have repeated vertices all over the place. We see B appearing twice. We see G appearing also twice. F appearing twice as well. And as we see, there are going to be some edges that get repeated too. And in a walk, that's totally okay. So we're going to start at B. There's our blue vertex. Then we go to E. That goes to another blue vertex. And I'm going to keep my same convention as in previous videos. If we go over a vertex for the first time, it's going to be blue. And then we're going to change color, I believe, to green. And then if we go over an edge the first time, it's going to be red. And when we go over it twice, it's going to change color to, I believe, yellow. But we'll see. It'll be exciting. So we go to B to E, then over to C, then back to B. Notice that we've still only gone over that edge between C and B once, but we've gone back to B twice for the second time. Then we go over to G, over to F, down to I, back to F along the same one. So now we have an edge that's been used twice. That vertex has also been traveled on twice. We're at F now. Back up at F. And then we go back up to G. Now that edge has been traveled over twice, and G has been traveled to twice as well. So as I mentioned before, it's perfectly okay in a walk to repeat vertices and repeat edges. Not in some of the special walks that we'll get to in the future, but right now, repeated vertices, repeated edges, okay. So for a path, it's a little bit different. A path is a walk. It looks just like a path graph, and all that means is there are no repeated vertices. Every vertex in the path appears once or not at all. All right, so here's our graph again. Here's our example of a path. Notice that all the vertices are different. So if we start at C, we go to E, we go back to B, we go over to G, down to H, and down to I. And notice that we never had to change colors of our vertices. And actually, because of that, we never had to change colors of our edges as well. If you travel over vertices that are different, the edges are going to be different as well. When that distinction flips around, it's going to be a little bit different when we talk about trails, so just keep that in mind. Now, cycles are just like path, except we don't have any repeated vertices, except the last vertex is going to be the same. So the first vertex is going to be the same as the last, but otherwise all the vertices are different. So here's our little graph again, and here's our example of a cycle. Notice that we have a B at the beginning and a B at the end, so that's where it's going to begin and end. But notice that all the other vertices are distinct. So if we start at B, we go down to E, over to F, over to I, over to H, over to G, and then back to B. So B is green because we hit it twice. Everything else we hit once, including all the edges. Again, B appears twice in the cycle, and at the beginning and at the end. So now we get to something new. We're going to talk about trails. So a trail is just like a path, except instead of in a path, we have the vertices aren't allowed to repeat. In a trail, the edges aren't allowed to repeat. So a trail is a walk in which no edge appears more than once. But as we will see in our example trail, even though the edges can only appear once, the vertices can appear more than once. And we'll see how that happens. So here's our graph. Here's an example of a trail, and just looking at the vertices of the trail, you can see that B appears twice, the second one and the fifth one, and the E appears twice as well. That is going to be the fourth one and the last one. All right, so we start at A, we go to B, go down to C, over to E. We go back to B, and notice that even though we don't have any repeated edges yet, B has been visited twice. Now we go out to G, over to F, back to E. E has been visited twice, but again, our edges have only been visited once, and then that's the end of it. That's where we end. All right, so again, no edges repeat, but the vertices can repeat, and not just one vertex, the beginning and end or whatever. Any vertex within that trail can repeat, as long as there are no repeated edges. Now a circuit is going to be just like a trail. In fact, it is a trail. The only difference is it behaves a little bit more like a cycle in that it begins and ends at the same vertex. So trail means no repeated edges, but what makes it special as a circuit is that it begins and ends at the same vertex. So again, here's our graph. Here's our example circuit. Notice we begin and end at E, and actually on this one, you see we visit E 3 times during the circuit, at the beginning, at the end, and it's also the fourth one to be visited. So let's see. So we start at E, we go over to C, we go up to B, we go back to E. So we visited it twice, but notice none of the edges have been visited twice yet. We go over to F, then to G, then to H, then to I, back to E a third time, which is rather amazing. So we visited E 3 times, and yet still only hit each edge only once. All right, so now that you've seen these examples, go ahead and look at Introduction to Eulerian Circuits and Trails on the PDF file included with this video. You notice that extra word Eulerian. It just means it's going to be a special type of circuit. You'll see what it is. It'll be explained very thoroughly in the in-class activities. And of course, if any of that's confusing to you, you are welcome to ask me in class.